And so before I get started, I want to talk about how we can map or recognize these mathematical relations. One is we could do a thing called ordered pairs. Now the ordered pairs is just one way to represent the data. So usually that's when we graph things in the xy plane. So I could say -3, 4, 3, -1, 4, -1, and whoops, I want -1, -1, and then 4, 3. So that's one way to do it. Another way that we could do it is we could do what we call mapping. Now mapping is kind of a cool thing because what I could do is I could take these values like -3, 3, and 4 and then map them to other values such as 4, -1, and 3 and just draw a line like this. Now it's the same as what I have here. I'm just saying that -3 has some sort of mathematical relationship to 4. Now generally, this is usually the input value and this is the output value. Also, and we'll talk about this, this is, in most cases, the domain, and in most cases, we would call this the range, if we were talking about functions. Okay? And usually this is associated with the x, and this is associated with the y. We will be using some function notation. So function notation, sometimes you'll see the y represented as f of x. Okay? Does that make sense? Is that any better? Can you guys slide over? All right. Now there's another way to represent the data. We could do a table of values. So now for a table of values, we would just represent it this way. We would say -3, 4. 3 corresponds to 1. 4 corresponds to 3, and so on and so forth. Again, all these x values, this is the input. All the y values are the output. And this is associated with the domain. This is associated with the range. Any questions about that? Now, one other thing that we could do with these numerical values, we could actually use a third type of representation, and that would be a graph. Now, this would be what we call a two-dimensional Cartesian plane or a two-dimensional XY plane. And this you're familiar with. You have your x and y axis. And so, for example, the first number, like -3, 4, would represent the x direction. So this would go 1, 2, 3 in the negative direction, and up 1, 2, 3, 4. That would give me the point negative, if I were to put the point right here, -3. Let me move this over a little bit. -3, 4. Right? So that's the x, y value. Or these are the positive x values, these are the negative x values, going up is a positive y value, and going down is a negative y value. Now, do you guys remember how to do graphs? So is there anything new about that? All right. So now let me move on to example number 1, if I can. Example number 1 on your textbook says, it talks about a jumper jumping out of a plane. So I'll read it out loud, and then we'll try to use some math and see what we can predict or figure out if there's a relationship or not. It says when a skydiver jumps out of a plane, they experience free fall. There's some photos in your book, and it says the photos show various heights of the skydiver at different times during free fall, ignoring air resistance. How can you represent this relation 4 different ways? And so they tell you, based on the pictures, they do this like input-output thing. And so they say, when this is 0, you're at 10,000 feet. After, and I think the input is just the time in seconds. Yeah, so this is like in seconds. And this is in feet. Okay? So after 1 second, they're now the skydiver is down to 9,744.
That's 4 seconds.
Oh, you know what? This is 4 seconds. Is that what you shouted out? That's okay. Thank you. Thank you.
No problem.
And then 12 is 7,696. And then at 16 seconds, 5,904. All right? So when we look at that, what does that look like? That kind of looks like a table of values. In fact, if I wanted to make a table of values, I would just say x comma y, and I would say 0, 4, 8, 12, 16. It almost seems silly that I'm writing it down, but that's okay. All right. Then another way to represent that, I could do ordered pairs. So this would be 0, comma 10,000. And what your textbook is, they put it all as a set, sort of. The next one would be 4, comma 9744. 8, comma 8976. 12, comma 7696. And then lastly 16, comma 5904. Okay? So that's if I were to represent that with ordered pairs. And so now to graph this, what I'm going to do is I'm going to click on my stat button and I'm going to click edit. Okay? And what I would like to do is I got to clear this out. So you may have some stuff in there. Go up to L1 if you have stuff like that. And hit clear, then hit enter. Next, use your cursor to go up to L2. And then hit clear, and then hit enter. And so I'm gonna, let me move this over so I can see my values. So I'm gonna enter in 0, I'm gonna do all the x values, 4, 8, 12, and 16. Then I'm gonna go to L2, and I'm gonna put in all the output values. So the first one is 10,000. The next one is 9744, 8976, 7696, and then 5904. Did you guys get all that? If I hit second, and y equals, that takes me to the stat button. Now, Mr. Adams already has his turned on. If you don't have yours turned on, what you do is you just hit enter and move the cursor until it's highlighted over on, and then hit enter.
Wait, mine doesn't look like that.
It might look a little different if you have a different calculator.
It just says off for all of them.
Okay.
Wait, enter?
Hit enter on plot 1.
Hey,
Right now I see it.
Okay, good. The x min and value, remember this is the x values and these are the y values. What's the minimum here?
0.
The minimum is 0 for x, and what's the maximum?
16.
So the maximum is 16. Now the y minimum is this number, and this is the max. So when I set this up on the calculator, right, when I'm trying to do this on the calculator, that's what I'm setting up. So my x, for the minimum x is like 0, and the max is like 20. And then my minimum is like this, but I'm going to change my... So I think that's good, right? The minimum, oh wait, I screwed up. This needs to be 4,000.
That was the loss.
And this needs to be like 11,000. We'll go a little bit above and below. There we go.
Is that?
There it is. Yeah, I got it now.
I don't know.
Whoa.